Class Engineering, and today we're going to discuss about the Laplace transformation. Yeah. First of all, why we need to read the Laplace transformation. And for the Laplace transformation, that means for solving the ordinary differential equation and the integral equation, we need to understand the basic concepts behind the Laplace transformation. So, the for the Laplace transformation is denoted by the L function L LFT, and any function LFT, that L of any function LFT is defined as the Laplace transformation, and it is denoted by the L. Function in the T space, function in any space T is converted into function in the any space S space, which is also known as the function F is known as the Laplace transform. Let's see the definition of Laplace transformation. Here, the Laplace transformation of a function, that means, okay, Laplace transformation of the function ft, Laplace transformation of the function ft greater than definition. This is the definition, and the Laplace transformation of the function for ft t greater than equals to 0 of the ft, and this function is denoted by this function ft is denoted by the fs equals to integral 0 to infinity, and the equal exponential function minus st and ft dt, where s be a any constant, any constant, and s be a complex number that belongs to complex number, and for this the s must be greater than equals to greater than 0 for this. And this is the and function t is changed to function f, yes, which the Laplace transformation of this function. Okay, this one is the simple definition, and let's make some numerical problem for clarification of this. Okay. And here the Laplace transfer of the ft is defined as the LFT. This is the L. LFT equals to Fs. This is the simple one, and the inverse inverse of the Laplace transfer. That means if you write, and if we write LFT, if you write the LFT and the ft equals to L inverse Fs, then ft equals to ft function is equals to L inverse Ff, and this follow the identity relation here. Laplace of the f, Laplace L equals to bracket, and the Laplace inverse, the product Laplace inverse equals to Fs, and the Ls and the LFT equals to Ft. This one is important for solving some numerical problem. Okay, let's make some simple numerical problem. Okay. Okay, and we know that the function Laplace inverse, Laplace of the any function ft Laplace ft equals to integration from the 0 to infinity, and this 0 to infinity e to power minus st, that means exponential minus st and ft be any function, and function in terms of a t and dt. And let's find the Laplace of the one, that means any constant one, and let's use the same formula, integration from the 0 to infinity. This one is the 0 to infinity, and the exponential minus st e to power minus st, and the function is 1 and dt, and 1 is no more, and for integration of the exponential function, integration is same st, and for integration constant divided by minus s is a constant, yeah, and minus 1 is constant from 0 to infinity. And if you made this and e to power minus st and e to power minus st, what is the condition of the e to power minus st, and put the limit, and e to power minus infinity into s upon minus s, yeah, minus times the e to power minus 0 divided by minus s. Okay, let's put e to power minus infinity, to 1 by infinity equals to 0. This term is 0, and minus minus plus, and this term is also a 1, and divided by 1 by s, and your final answer is then you got the one relation that the Laplace inverse of any constant 1 equals to 1 by s. Yeah, so interesting. Okay, likewise, and we have a different types of formula. Let's just focus and let's discuss the some formula. That means the Laplace inverse of a t power n, that means the t power n be any number equals to integration of the 0 to infinity e power minus st e power minus st e power minus st dot function is t power n dot dt. And this one is so simple and so important, and we're gonna write it directly into a relation. That means the gamma function of the n plus 1 divided by s power n plus 1 s power n plus 1. For this, n plus 1 must be greater than 0. Yeah, so and gamma function can be again elaborated and changed into n factorial divided by s power n plus 1. Another relation here, and here is the one important relation. That means the gamma function of the n plus 1, gamma function of the n plus 1 equals to n factorial. For this n must be greater than equals to 0, and the must be greater than 0 equals to must be n the numerical value. That means n be any constant must be greater than 0, because the negative of the factorial is not undefined. Okay, this is the t power n. And for this if you want to find the Laplace inverse and the Laplace inverse, and you need to find the Laplace inverse and the Laplace transformation like simultaneously. And just like here, just like Laplace inverse of 1 by s equals to Laplace inverse of a 1 by s equals to how much? 1, because Laplace transformation of a 1 equals to 1 by s. Laplace inverse of a 1 by s power n plus 1 equals to and function, what is the function? And t power n divided by n, t power n and t power 1 is the function. T power 1 t power n divided by n factorial, or t power n or t to the power n divided by n factorial is, again you can write the gamma n plus 1. This one is the formula 1, and this one is the formula 2. Yeah, this one is the very very important formula. Likewise, and we need to derive the one of the another important formula, that is for the exponential function. Okay, let's do some important calculation right over here. For exponential function, that means the Laplace transfer of the eco power a into t. That means the at equals to any function a be any constant and t be any variable. That means the from the 0 to infinity, 0 to infinity eco power minus st dot function eco power at. Okay, let's change it, the dt. Yeah, the dt. And let's make some rearrangement. 0 to infinity and the eco power a minus s. Yeah, put some brackets right over here, and the t dot dt. Yeah, and this one is the exponential function using the constant a minus s. And you're gonna do the again the differentiation, again the integration of the eco power a minus s t and dt. And let's do it. This integration equals to okay, let me rub this something right over here. Yeah, integration of the that means integration of the 0 to infinity eco power a minus s dt. Yeah, dt. This one is the integration of the eco power a minus s t divided by a minus s is constant from the limit from the 0 to infinity. Put the limit right over here, plate for the infinity, and the eco power a minus s to the power infinity. That means the eco power infinity, simply. Yeah, and the another one is the a minus s, and minus the eco power a minus s bracket into 0 divided by a minus s. Yeah, a minus s. And here we go, eco power 0 equals to 1. Yeah, we know that. and something to power infinity, and something to power infinity a minus s, this one is the infinity, and 0 by 1 by something, and equal power infinity, and infinity multiplied by anything is equals to infinity, yeah, only that. And a minus s equals to 0, that means this is the 1 and this one is the 0. Let's put it, and again, yeah, again, and this one is the 0. Oh, no. And this term is 0 minus this one is 1 by minus a by s. Okay, this one is and the 1 by a, and minus 1 by a minus s, and we can write this as a 1 by s minus a. This one is the final relation you get here. So we can write directly, that you got a one formula. Got a one important formula from integration of the EAT, and our formula is, okay, let me edit this too. Okay, let me edit this too. Okay, integration of, I mean, and integration, oh no, no integration, Laplace of Laplace of EAT, exponential function, that means the Laplace of exponential function, this one is the Laplace of the exponential function EAT equals to 1 divided by s minus a. And for this, here e is a positive term, and again Laplace of e minus at, and one is sign is different, so, and 1 by s plus a. So this one is the formula. And for this, if you want to find the inverse of this function, okay, let me write the inverse. Simply first write the Laplace transfer of each function, then simply put the inverse. The Laplace of EAT equals to 1 by s minus a, and that means the Laplace inverse of 1 by s minus a, 1 by s, no, s minus a equals to EAT. Yeah, so simple, EAT. And again, if you want to say, and the Laplace inverse of s plus a equals to minus 80. Yeah, this one is so simple, and hope you guys understand this. And we're gonna find that different and another part 2 video. Okay, wait for the next video. Okay, bye.